All right, well, welcome back here. Let's continue talking about these polynomials. In the last video, I had outlined 3 of the major theorems that are stated in this section, and now we're going to try and apply this. So here's a problem. It says find the zeros of the polynomial function and write the function as a product of its leading coefficient and its linear factors. Well, this one's a really simple one, right? Because what is the leading coefficient? It's equal to 1, right? So let's rewrite p of x a little bit so that we can see the leading coefficient at work right here. I've got p of x is equal to 1x cubed. And we want to write this in descending order of terms. So we're going to write minus 2x squared plus 9x minus 18. Okay. Now, what our fundamental theorem stated was that if we have a polynomial of degree n greater than or equal to 1, then p has at least one zero in the complex plane. Not only that, but we know that it's a third degree polynomial. We should be getting 3 linear factors from this polynomial. And then finally, that we would be able to get 3 zeros. So what do? Well, this is actually a very straightforward one because we don't have to do any fancy footwork. We know that this is going to be a polynomial with degree 3, so we should be able to factor it apart. And this one actually factors by grouping. So let's just run through grouping again. In grouping, I take the first 2 terms, the last 2 terms, and I just try to look for any common factors and see if I can uncover a common binomial. So what have we got? P of x is equal to x squared, 1x squared, pardon me, times x minus 2. So can we factor out on x something to give us x minus 2 in the next term? Well, yes. If we factor out 9 times x gives me 9x, and 9 times minus 2 gives me minus 18. So now we actually have p of x equal to 1x squared plus 9, and why I'm writing the 1 in front of that will become apparent in a moment, I hope, times x minus 2. So we need to find linear factors of x squared plus 9. But I happen to know that x squared plus 9 equals 0 whenever x squared is equal to negative 9. And since this is a negative number over here, when I isolate x by taking the square root of both sides, I will get positive or negative 3 times I. What that means is that my polynomial p of x will factor as 1, the leading coefficient, times the linear factors x minus 3i and x plus 3i, 2 complex number zeros, times x minus 2. So now if you compare this with our polynomial theorem on the earlier page right here, p of x, an nth degree polynomial, in our case a third degree polynomial, factored into a leading coefficient times the product of its following factors right here. There it is, right? And we can say that our zeros are going to occur at x equals 2, which is the same as saying 2 plus 0i, so it is a complex number, right? As well as x equals positive or negative 3i. 3i. That's not very good, 3i, Professor Peoples. Let's try that again, 3i. Okay, so when we're looking for factors of a polynomial, we're looking for the values that are going to give us A, the linear factors, and B, we can get the zeros directly from those by setting the polynomial equal to 0. All right, so I'll do another example here in the next video.